All right, let's get started. Lecture 40, which means we only have one lecture left. If you probably noticed what I was doing right before class, but I'll explain. So there's 5 piles here. This one says A through D. This one says E through H, I through M, N through S, and T through Z. This is organized by last name. This is your exam 3. And then I don't know why I kept them. I said I was going to get rid of them. For some reason I didn't. I have your exam 1s, okay? Please do me a favor after class by pile. I also clipped them together so that, you know, each student's by paperclip, everything that's outstanding that that you haven't picked up yet is here. Sound good? Okay. All right. Homework 7 is due today. That is your last homework in Engineering 213. Okay. Other than the bonus assignment, which well, I'd say about half of you have done. I didn't collect the data as to who uploaded and who submitted. As the professor, the only thing that I can see on my MU is how many people have done it. And usually what happens is there's more people that have done it than uploaded the screenshot. And they're free points. So again, you can say I'm the worst professor ever, that you've hit your limit with my math jokes. But again, if you upload it, it's free points. And so I say 2 remaining bonus. It's meant 2 remaining assignments that need to be graded: the homework 7 and then the bonus assignment. I know that was a mistake. I meant 2 remaining assignments: the homework 7 and this. That's what I'm sorry. So I know you're like, what, 2 assignments? I'm sorry. Whoops. I meant 2 assignments. But yeah, here's another typo. I know I'm just full of typos. This right here is supposed to be Monday. 7. But again, I'm the one that keeps track of the mistakes and reports them to the university, so I know it's a corrupt system because I never hit 7. Yeah, it's corrupt, I know. But December 6th, I was saying 7. 6, Monday, December 6th.
I think we just hit about 9.
No, you hit about 0.9. That's what it was. All right. I want to talk a little bit about the logistics for the exam. I'm going to go through the topics that we have covered in this course this semester. And then what I'm also going to do, because this isn't going to take the entirety of of our time together, is I'm going to talk to you a little bit about some advice that I have for you for the final, but I'll get to that here in a bit. First off, okay, so a couple of things. The exam will be on Friday, December 10th. It will start at 12:45 p.m. and it will go to 2:45. It is a comprehensive final. It's designed to be the 2 hours, but I design it to be 100 minutes long, not 120, because to me it's, you know, we have a 50-minute class, and so this is kind of like 2 class periods. I'm going to talk to you a little bit about the types of problems that you might expect for the final, and I'll even give you a sneak peek into one of them so that you can maybe kind of get an idea of what to expect. Other than that, the logistics are probably going to be very similar to exams that you've done in the past. Everyone will be given a set of blank computations to use for scratch work, and I am going to distribute a survey during the exam that I'd like you to complete. But basically, you've probably done this in some of your engineering courses before, but it's going to ask you specific questions about how you think the objectives were met in the class. So, you know, do you think you can add vectors on a scale of 1 to 5? Do you think you can compute the location of a centroid on the scale of 1 to 5? Stuff like that. I'll distribute that through the exam as well. That's obviously not graded. I am also going to ask on that your major, but it's the only thing I'm going to ask that's of any identifying information to you, because in order for our ABET assessment purposes, we have to make sure that we're assessing each of the students in the different degree programs. I got civils, mechanicals, biomedicals, et cetera in here. So that's the only thing that'll be asked. But again, just be honest. The data helps us improve the courses that we teach in the future. Same process as before. The timer with auto submit is going to be for 120 minutes because it's a final. It's a 2-hour final. But again, it's only designed to be 100 minutes long. And I do still use the rule of 3. Same deal, open book, open notes. You just can't use another individual, no forums, no chegg, stuff like that. As for the format, it will be probably like 8 to 10 conceptual questions, no more than 1 or 2 sentences, and I'm going to talk about that here in a little bit. I hit the chair. You're looking at probably like 4 to 6 computational problems. Do me a favor, again, as before, please type out an answer for every question. One of the things I will tell you about the computational problems is that they will be similar to what you've had on previous exams, but they will be shorter, okay? I'm going to give you an example so that you understand what I mean. And a visceral example, let's say the centroid problem. So the centroid problem that you had on the last exam was a shape, let's just say, that required multiple rows, like you needed multiple rows. And for that problem on the exam, you were looking at centroidal computations for the x and the y-axis. So a similar problem on the final might be a centroid problem, but it would be a simpler shape that might not need as many rows, and I would probably only ask you for, let's say, the y-axis and not the y and the x. Does that make sense? So they will be similar problems, but they will also be smaller in scale, okay? Because I'm going to ask you more of them. Does that make sense? I'm not trying to ask you the most complicated problems I can think of and ask you twice as many as I've had on previous exams. That's not what I'm trying to do, okay? I am going to assess your understanding of this course as a whole, but I'm not trying to put you through the ringer, okay? Does that make sense? All right, let's talk about the topics on the exam. And then before I open it up for questions, and we're going to open it up for questions on Friday as well, but I do want to talk about, the topics, and then I'm going to talk about some advice that I have for the exam. So here's the topics on the exam, but really this is what we've talked about this entire semester. So in terms of the fundamentals, these are some things that I think you need to understand. So first off, I think you need to understand classical motion, you know, position, velocity, acceleration. Make sure that you understand Newton's 3 laws of motion and be able to describe those. I want you to be able to compute the weight of an object. I think that should go without saying. You should be able to convert units and perform dimensional analysis as appropriate and employ concepts in algebra and trig. And I would argue that if there's any one mathematical skill that's been necessary this semester, it's been the trig. In terms of our first main topic of the semester, that was particle statics. So you need to understand properties of vectors. So remember, what's the difference between a scalar and a vector? You need to be able to add vectors. I'll go ahead and tell you that your main skill that you'll probably need to employ when it comes to adding vectors will be adding by components. So one of the things that I try and do on exams like this is I don't try and micromanage you. I want you to have the freedom and the ability to assess the problem the way that you think makes sense. And I think that it's easier to take vectors and write them in IJ notation and add up the components than it is to do the trig stuff. I think the trig stuff is necessary so that you understand the basis for IJK notation, but I think IJK notation is easier to employ. You do need to be able to apply equations of static equilibrium to solve 2D and 3D systems, and be able to solve 2x2 and 3x3 systems of equations. So I would definitely recommend that you bring a calculator that you are familiar with, as I have said on previous exams. At a minimum, make sure it can solve simultaneous systems of equations, 2x2 and 3x3. We're now into exam 2 land. Exam 2, you needed to be able to compute cross products and dot products. Again, most of your calculators can do cross products. I would imagine that cross products might be a bit clunkier than something like a 2x2 system, but they can do it. And so at a minimum, it can check your work. Be able to compute moments. I think that's probably, this course, there are 2 fundamental concepts in this course. There's an old saying that statics is only about 2 things, that's forces and moments. So make sure that you can compute moments, and there are a number of ways to do that. The first is to use the classical definition of a moment, R cross F, R being the position vector, F being the force vector. You can also compute the magnitude of that moment by taking the magnitude of the force times the moment arm, the distance from the shortest distance from the point in question to the line of action of the force. You also be able to compute moments about an arbitrary axis, which is basically just taking r cross f and dotting it with the unit vector along the axis in question. So moments about an arbitrary axis will yield a number, a scalar. R cross f will yield a vector. Be able to resolve force couples and be able to generate equivalent force systems in 2D and 3D. So that's taking a bunch of forces and moments and all sorts of stuff on a system and resolving it into just a single force and a single moment. Finally, rigid body equilibrium, be able to compute support reactions for 2D and 3D systems to satisfy equations of equilibrium. That's support reactions. I got a comment I want to make about that here in a bit, about advice I have for you for the final. Exam 3 land, we're in centroids and structural analysis. So for exam 3, remember we said that you need to be able to compute the location of a centroid, of either a line, an area, or a volume, and be able to compute the moment of inertia of an area. For structural analysis, be able to compute, be able to compute the support reactions. Again, that's just sort of a repeat for rigid body equilibrium. I would say for some of you, the computation of support reactions should be a key focus of your study habits, and I'll explain why here in a bit. But be able to compute internal forces in members of plane trusses, that's either the method of joints or the method of sections, and be able to draw shear and moment diagrams for beams. And finally, this is the only topic that I think is new that we haven't had an exam on, and I will tell you there will be a direct problem on friction, is be able to determine equilibrium conditions for objects in direct contact. That's what we've been working about for the last couple of lectures. For references, again, this slideshow is uploaded to Blackboard, and as I've done with previous exams, I like to have a single PowerPoint that has hopefully 90% of everything that you would need, all the formulas, equations that you would need to negotiate the final. I really don't like you having to go on a hunting expedition to find all the formulas and references. This is my best attempt to put them all in one spot in a concise fashion. So here's our fundamental equations and concepts. Weight is mass times gravity. Here's the definitions of gravity in SI and US units. Our base units and some definitions and conversions. Trig, the trig preliminaries, law of sines, law of cosines, basic trig functions, rectangular, polar, etc. The basics of vectors. So remember, vector addition is tip to tail. Here's the definition of our IJK basis unit vectors. We have really what I think is probably the most user-friendly tool with vectors, and that's converting them to IJ or IJK format, because you can add up the components directly, and it's really easy to determine resultants as long as you've got your angles and sines accounted for appropriately. Vector expressions in 2D and 3D, I think this is probably one of the most useful references for exam 1, because everything related to adding vectors is all in one slide. Also, if you want to determine unit vector orientations and angles of orientation, that's all located there as well. Here's the formula for the cross product. Here's the formula for the dot product. I think that one's pretty easy to do just by hand. The formal definition of a moment, recognizing r cross f and moment arms and so on and so forth. And then we have moments in 2 dimensions. Computing moments about an arbitrary axis. Again, this is probably the trickiest thing that we've done, I think, in this entire course. So again, I'm not trying to be super tricky on the final. I'm not saying you're not going to have a problem like this, but I'm not going to try and trip you up. Force couples, again, I don't think there's really any additional math or formulas that go along with that. It's just a concept that you need to be aware of. Equivalent systems of forces, this is definitely something that could be on the exam. Recognizing that 2 systems are statically equivalent if the sum of forces in system 1 and the sum of moments in system 1 equal the sum of forces and moments in system 2, respectively. Static equilibrium, I am not going to get inventive on the support conditions. Hinges, rollers, pin supports, fixed supports, like that's it. It's not going to get super wonky with the support conditions. Same thing with 3D. It's not going to get wonky there. I'm not going to get symbolic, I'll tell you that. Same thing that I said, and I don't think I did that on exam 3. I don't plan to do that on exam 4. I do think you need to understand the basis of where, h over 3 and the centroid formulas come from, but I'm not going to get wild with it. This is probably a very handy thing to have on hand, your centroid reference, the table that lists, h over 3 and 4r over 3 pi, et cetera. I think that's pretty valuable for you. Same thing with 3D, although, again, I don't think I'm going to get too spicy on that. Moment of inertia of composite shapes, I think that this is a good topic to study, but these problems are pretty long and kind of involved, so I'll go ahead and admit that. References for moments of inertia, though, I might ask you some conceptual questions on that. Method of joints, method of sections, the mathematical and derived relationship between our load, shear, and moment, and then the conclusions that we used for shear and moment diagrams. Here's just the patterns for shear and moment diagrams. And then our static and kinetic friction. That's the last thing that we discussed. Before I open it up to questions, I do want to pull something up. Discard. Hold on. I do want to pull something up. This is something that I was actually going to talk about tomorrow, but I think that it would be a good idea to discuss today. And these are some suggestions that I have. So I was talking with some students in here, and I think that there might be a few students that either didn't realize or haven't seen them yet. But if you go to Teams, you will find that on Teams, at the end of every exam, I recorded a little video where I went through the statistics of the exam so that you knew what the class average was, how the class did on each problem, et cetera. And then at the end of that discussion of statistics, I came up with some suggestions that I thought would help you on future exams. And to be crystal clear, what I was not trying to do was say, here's everything you did wrong, and shame on you. It was genuinely because this is stuff that I think would help you do better on future exams. And since the final is comprehensive, I thought it would be a good idea to just collate all of this and say it all at once. So these are some suggestions that I had from exam 1. I think that time management is key, but I also think you should kind of focus on problem weights. And one thing I'll say off to the side, some of these pieces of advice I think are going to be valuable not just for the final in Engineering 213, but for the rest of your collegiate career. So I think that this is something that you should think about. Problem 1, I asked you, or exam 1, I asked some conceptual questions and the computational questions. Some of the conceptual problems were only worth 4 points, and I got some Shakespearean sonnets for some of the answers. And sometimes the simplest answer is best. And one of the things you'll see is that I've collated the advice for all 3 exams, and some things are going to show up multiple times. So they're definitely things I would think about reviewing. Definitely read the problem and answer the problem. What I mean by that is there's been some instances, particularly on exam 1, but in other exams, where you're doing calculations that don't really get you towards the answer for the problem. On this exam, there was a problem where all you needed to do was compute the length of a cable. And I've got students doing 3x3 systems of equations, and they spent way too much time on the problem because they were unrelated to the task at hand. And I don't want to see you do that. Answer every question and show as much work as you can. The more work that you show, the more I understand what you were doing. And the more that I understand what you're doing, the more room that there is to award partial credit. I'm a partial credit guy, but if there's nothing to award off of, there's nothing I can do. So, and that, I think you'll find that professors that want to award partial credit, it's hard if there's nothing there. So make sure you show your work. It is usually not a bad idea to independently repeat each of the calculations you perform. I guarantee you the class average for every single exam I've had in here would probably go up a couple of points if you have a formula, you do the math, and then do it again, okay? Because you should get the same answer. With a class this big and the complexity of the problems that we do in here, there's bound to be calculator mistakes. And I don't take off a lot for stuff like that. But by repeating it, you're checking your work. It's sort of like when we do examples in here, and I ask, what's the answer to this, and then say, do I have a second on that? It means 2 people got the same answer. They went through the same process and got the same result. Exam 2, I had the same suggestion on read the problem, answer the problem, and the same suggestion on problem weights. One of the other suggestions that I had on exam 2 is to not make a problem more complex than it needs to be. And I think that that also goes to some suggestions that I would have on organization. The last thing I'm going to do is fault somebody for their penmanship. I mean, we've got, with a class this big, again, there's a spectrum of beautiful handwriting and not so beautiful handwriting. But there is a difference between neat and poor handwriting and neat and poor organization. And if you're trying to skip steps or consolidate steps or use these incredibly involved approaches, and then you combine that with a lack of structure and organization to your computations, it can make for a bad problem. So I definitely think it's worth it to take the problem, take a second and go, what do I need to do to solve this problem? Break it into steps and do each of those steps one at a time. Exam 3, sometimes the simplest answer is the best, okay? So for that one problem on, the first problem on exam 1, I got some, again, Shakespearean sonnet answers. And then there were students that wrote D-O-N-U-T and got full credit. So think about, the simplest way of answering some questions. This is engineering, okay? So keep that in mind. Don't skip steps. What? Oh, don't skip steps, okay? This was, I think, a big issue on the last exam that we just took because, like, for example, there were students that just didn't compute the support reactions for the truss, and that is not gonna lead to a good time. And there was a big one on problem 7 where a lot of students drew the shear diagram, got it 100% right, and then integrated it and looked at the numbers and went, oh, it's not going to work, instead of actually following through and drawing the moment diagram. And if you had followed through and drawn the moment diagram, you would have gotten a different conclusion. But because there was some steps being skipped, it didn't lead to the correct answer. And I know that there's a time consideration to go into that, but I think that that's necessary. But my final piece of advice actually tethers to the third exam, and it's this last bullet. If on your third exam you missed the reactions for problem 6 and 7, that's what I think you should study, if there's any one thing. I'm not saying don't just study that, but I definitely think that you should, because there are skills developed when you learn how to compute support reactions that apply to multiple areas of Engineering 213. As an example, when you compute the location of the centroid, what do you think those x and y distances are? They're moment arms. They're distances from a chosen point, a chosen origin, to the centroid of a shape in question. Those are moment arms. That's all those are. And if you understand that, that conceptual understanding can translate to other areas of the exam. And you also, let's just talk about support reactions. That is just a topic in and of itself in this course. You have to have correct support reactions in order to get correct shear and moment diagrams, in order to correctly analyze a truss. And so if that is a sticking point, I would focus some study on that. I think it will definitely improve your performance on the final. Okay, all right. Now it's 1:25. Let me tell you what my thoughts were for the next sort of little bit and for tomorrow. I'm happy to go through some problems. I'm happy to address some conceptual questions and logistics on the final. Also, if you want, if there's some problems that you'd like to do, and maybe we don't have time to do them today, that's sort of the whole point for between now and Friday. If you've got any problems that you'd like to do, think about them, and we can spend all day Friday doing those too. But with that, I am going to shut up for a second and open the floor to you. If you have any questions, I'd love to address them. It would help if I walked away from the spotlight so that I could actually see the class. Did me going through 20 slides of concepts freak you out, or I hope not. Does anybody have any questions? Wow. Let me ask you this before I'm not going to just cancel class now, but let me ask you this. Is there a desire to even have the review session on Friday, or does everybody think they're good? I mean, my plan was to be here. I know that last year when we had the comprehensive review, people wanted the review on Friday so that we could go through some problems. But I mean, tell me what you think. This is your time. Like I've said before, whether it's scholarships, loans, your parents, somebody's putting cash money on the table for you to be here, so I want you to get your money's worth. So what do you think? Yes for Friday. Okay, all right, we'll be here. We'll go through some problems. Let me ask you this. Is there any topic on Friday that you really want to do? Like, is it centroids? Is it what? Like, because I'm not saying that we'll do just one topic, but with the limited time, I want to make sure we're getting our most bang for our buck. And you don't have to answer now. You can post that on Teams and we can prepare it. But if there's any problems you'd like me to prepare, I can get those ready in advance. By the way, I did post exam 1 to Teams with the answers. But I didn't post like the worked out solution because I think the whole point is you need to work through it and get the answer. What do you think? Is everybody just wiped up for us after this semester? Yes, sir.
What would you like for Christmas?
I already have my 2 front teeth, so I'll have to think about that. I wasn't expecting that one. I was expecting so are you teaching dynamics next semester? Yeah. No. No. Now we get some discussion from the class. Yes, sir.
Okay, so for the final, are there going to be maybe problems that weren't on previous exams on purpose that could be fair game, or is it just like stuff that was on previous exams?
So that's a good question. Here's what I'll say. I'm not going to regurgitate a problem on the exam and change a 2 to a 3 and say, here's the problem. But what I am not going to do is throw some ridiculously tangent topic out of left. I'm not going to do it. And I'm going to give you an example so that you understand. So do you remember when we were doing our discussion of centroids, and there was a discussion of distributed loads, right, on beams? And so one of the things that we did for distributed loads on beams is we would talk about not just like a uniformly distributed load, but we would have like trapezoidal loads, right? Remember that? Okay, does everybody else remember that? You know what I'm talking about? Okay, when we were discussing that, we were discussing how to compute support reactions for those cases. What we did not do is say, okay, now draw the shear and moment diagram for a trapezoidal load. That's different, okay? It is conceptually different. It is mathematically different. I'm not putting that stuff like that on the final, okay? For one, I mean, so the math gets a little crazy, right? It goes from a linear load diagram to a parabolic shear diagram to a cubic moment diagram, right? That's what happens, okay? 2, I don't think it's necessary. This is a course on fundamental engineering mechanics. I'm testing your ability on fundamental engineering mechanics. We're not getting into advanced structural analysis. Do you know why? Because that particular topic, we have a class for that. We call it structural analysis, and the civil engineers are going to take that next year. You know what I mean? Because they need that, right? The other disciplines don't need that as much, so we don't cover it in here, okay? I'm not going to ask you anything so far out of the box that you can't handle it and you haven't seen it before. I guarantee you that the stuff that's on the final is going to be comprised of components that you've seen before. I guarantee you, okay? That doesn't mean that it's going to be a regurgitation of, I'm going to take this problem on the final and or on exam 3 and turn a 2 into a 3 and just ask it again. That I'm not doing. So, but that's a fair question. Is everybody, I'm curious how everybody's feeling about the final, because I want you to feel like you need to prepare, but I don't want you to feel like this is some insurmountable, you know, scaling the wall like in Game of Thrones. You know, I don't want this to feel like it's impossible. So, yes, sir.
For me, I just haven't had the chance to study it, so I don't know what I need to look at for.
That's fair. And I know that, like, I just dumped a bunch of stuff on you. I know I did. And I know that you're probably like, I know that there's a contingent of people in here that are probably like, okay, I remember all that, but it's dead week, Dr. Mike, and our caffeine's starting to wear off, and we're like, we don't know what the heck's going on. We need some time. I get that. That's okay. What I would ask in return is that it seems like the class wants to come on Friday and wants to come do problems, and I'm raring to go for that. But what I would ask is, if we are going to come on Friday, give me something to do, because I want it to be your review session. I want you to have some agency over it. I want you to have some control over it. There are probably some topics that are more critical than others. I'll just say, class did very, very well on centroids as a whole. I think you did, But then again, there was also, like, exam 2, that was probably the toughest exam. So do we spend time in class on that, or maybe not? I'm not trying to guide the discussion or lean you one way or another. What I don't want to have happen is I come in at 1 o'clock on Friday, I go, what do you want to do? And nobody says anything, because I want you to think about it, Is that fair? I mean, any other, we got time. We got plenty of time here. Anything that you're want me to clarify on the exam? Any conceptual questions you want to talk about? Yes?
Is there anything like 6 of the computational questions? Would it be like 2 for each exam, or is one exam going to have more weight?
Well, so I'll answer it this way. One of them is going to be friction. That wasn't on any of the other exams. The other thing I will say is, I think I can be fair and not reveal too much about the exam. Reactions show up on exam 2 and exam 3. And I'm not going to ask you like that type of question for both. You know what I mean? I won't do that. I do try and make sure that I'm not leaning too heavily into one exam or the other. So here is a potential scenario. I might say, here's a truss analysis that you need to perform, but I'm going to give you the reactions for the truss analysis. But then there's another problem where I'm saying, okay, compute the reactions here. So you're not having to do reactions twice. Does that make sense? And other than that, I am going to try and make sure that the exam represents the cross-section of the course, because I don't think that there's any one topic that's more important than others. I mean, forces and moments are what this class is about, and if there's anything I am going to try and ensure is that the computational problems equally address those two concepts. So. Would you tell me, would you like me to give you all a little bit of time to think of some questions to come back on Friday? Do me a favor. That's completely fine. Do me a favor. If there's something that you think I need to do some work on in advance, don't ask me Friday at 12:40. Give me a little bit of time to get prepared. Given that it's 1:35, we do still have some time. Does anybody have any questions that you'd like to ask now? I mean, we've got the time. Yes?
I didn't know if you said or not, but are you giving us like a list of review problems like we've had for the previous exam?
So that's a good question. I'll be honest, my inclination was to lean towards no, because I don't think that there's anything that I would add beyond the other list. But what I will do is post the previous 3 exams like I did before. So I'll give you, just so that you understand my timeline, I've already posted exam 1. My goal is to post exam 2 and 3 by Friday or Saturday. That's like my cutoff point there, if that sounds reasonable. And given that our exam isn't until the end of finals week, I think that probably gives you enough time. Sound good? My hope is that this is not like, I want this to be a fair assessment of your understanding of statics, but I do not want it to be the scariest exam in your life. I don't think there's any value to that. I think it needs to be fair, be challenging, and that's it. That's all it needs to be, Want to call it a little early, or? Okay, before we call it early, you would really be doing me a monumental favor if you got your handouts from up here. So again, they're in 5 piles according to last name. I tried to do that to make it quick. If you could go and grab these, you'd really be doing me a solid. All right, I will see you all on Friday.
I'm not gonna lie.